The North Sea, one of the most treacherous seas in the world, and beneath it, the promise of black gold, if you're prepared to take the risk. This is the United Kingdom continental shelf, the UKCS, and in the rocks below the seabed, down as much as 15 or 20,000 feet, is oil, millions of tons of it. In fact, the latest estimate is that under the seas around Britain, there's enough oil to see the country well into the next century. The problem is that to get the oil to the refineries is a difficult, dangerous, and expensive job. The oil companies have been working for many years in the North Sea and other seas surrounding Britain. But oil was only discovered here in the late 60s, the first big find being in 1968. And since that time, new technology, new equipment, and new expertise have had to be continuously developed. And that's where the Houlder offshore group comes in. Since 1972, the company has used its engineering skill and ingenuity to establish itself as a leading contractor in both exploration drilling and underwater projects. Houlder's expertise lies in designing, owning, and operating a variety of drilling rigs and diving support vessels. The company has been involved in some of the biggest and most innovative oil and gas development projects in the world, where Houlder Marine Drilling and Houlder Offshore Engineering have proved to be key figures in the group's success as a problem solver. One such project involved the Morecambe Bay field and the use of a new type of drilling operation, known as slant drilling. Discovered in 1974 by British Gas, Morecambe Bay is one of the largest known gas fields on the United Kingdom continental shelf, with recoverable reserves of about 5 trillion cubic feet. Early studies showed that to provide a uniform drainage pattern using conventional vertical drilling units would require up to 13 platforms, each supporting 6 deviated wells. However, the increased well step-outs made possible by slant drilling would allow the number of platforms to be reduced to 5, with a consequent saving on field development costs of more than £100 million. Costs could be further reduced by the use of a portable slant drilling rig, moved to each platform in turn by a jack-up support barge. British Gas commissioned 2 such barges, Morecambe Flame and Bay Driller. Development of the fields was planned in 2 phases. By late 1987, the first stage of Phase 1 was complete, comprising central processing, accommodation, and 3 drilling platforms. Stage 2, which provides for a further 2 platforms in the west of the field, is scheduled for completion in 1990. Management and support services were established at a new onshore base at Heysham, while the gas was piped ashore to the processing and storage facility at Barrow. Each unmanned drilling platform was designed to support 16 wells. There was a safety requirement to confine all the conductors within the platform structure. This was achieved by grouping in each corner 3 slant wells and 1 vertical well, which also reduced the number of rig skidding operations. Before transfer of the rig can commence, 2 hydraulically operated elevating beams are positioned on the platform. These are lined up with the jack-up support barge's cantilever beams. This is done with the aid of a laser. Once alignment is correct, transfer can commence. The rig has 2 sets of skidding surfaces, one on the wings used for transfer and the other on the bottom of the substructure for contact with the platform's skid rails. Powerful hydraulic rams on a support barge push the rig across a 10-meter gap onto the platform. The rig weighs about 650 tons, and the whole operation takes about 3 hours, including frequent stops for alignment checks. Once transferred, the rig is lowered onto the platform's skid rails. A separate jacking system is used to position the rig over the well slots. Jacks and pivots push and rotate the rig into position. The rig has to be maneuvered close to the platform edge. Care must be taken to ensure that the center of gravity does not cross a clearly defined safety line. For the final alignment, the derrick is lowered to its drilling position. A laser fitted to the rotary table indicates the drilling path. This is used to align a sighting guide on the cellar deck. The derrick can now be returned to its vertical position to allow skidding to recommence. The sighting guide, now replaced with a laser, still indicates the drilling path, allowing precise alignment, particularly critical for the slant wells. Finally, the hydraulic rams are removed and the rig clamped to the platform. The first sections of conductor are lowered to the seabed. An immediate check on the laser alignment is the ability of the 26-inch conductor to pass accurately through the underwater guides attached to the platform jacket. A 20-ton diesel hammer is pulled up the derrick on special extension rails. The hammering operation itself is similar to that carried out on conventional drilling units. Hydraulic arms on the derrick control each section of conductor pipe and align them for stabbing before the joint is made up with a talon connector. The conductor pipe is driven to 150 feet below the seabed or to the point of refusal. This is monitored by the tallyman and is set at 150 blows per foot. The conductor is carefully measured to ensure the correct space out for the well control equipment before the excess pipe is removed. The diverter is installed over the cut-off conductor and preparations are made to run the drilling assembly. Where possible, standard rotary drilling equipment is used on the rig. But working at 30 degrees inevitably requires some modification to equipment and technique. For efficient operation, the rig crew must become fully conversant with the slant package. Each new single is brought up to the rig floor on the hydraulic land racker and positioned in the mouse hole. A specially modified stepped rig floor has been placed around the rotary to make life a little easier for the crew. The joint is broken by an iron roughneck adapted for slant operation. Hydraulic arms push the Kelly over to the single in the mouse hole. The tongs have been modified to remain at 30 degrees while hanging from a vertical line. The driller, using the hydraulic arms, has total control over the new single as it is stabbed into the drill string. The iron roughneck makes the connection, and the operation is complete. A nudge from the hydraulic arm beneath the rotary table and the bushing is engaged. Since the slant rigs do not have a rat hole, the Kelly is racked on the right-hand side of the mast. Drill pipe must be transferred to the vertical racking tower to be stowed in doubles. Lightweight tubulars, such as drill pipe, are attached to a wireline system run between the derrick and the racking tower. Connections are broken and spun out using the iron roughneck. Hydraulic arms push the pipe end into the pivot cup, which serves as a fulcrum during the transfer. The wire line lifts the pipe from the pivot cup to be stacked at deck level. The top of the stand is racked conventionally. With heavier pipe, such as drill collars and bottom hole assemblies, a hydraulic racking arm replaces the wire line. The telescopic arm retracts, bringing the stand of collars to the tower, again pivoted in the cup. The stand is racked by an overhead crane. The casing is picked directly from the land racker. Extra long links are used for this purpose. The control afforded by the hydraulic arms is such that a casing stabber is not required. Connections are made using a conventional power tong hung at 30 degrees. A quick latch cement head is fitted over the casing. After cementing, the conductor is cut off and a conventional wellhead spool fitted. The BOP is cradled on the skid base, which moves over the well's center line and tilts to allow vertical or slant operation. In the severe weather of January 1987, the Morecambe field achieved an output of 955 million cubic feet per day, nearly 10% of national demand. With the completion of stage 1, production capability was increased to nearly 1,200 million. Innovative techniques have been tried, tested, and proven. The combination of Houlder Marine Drilling's operational skills and Houlder Offshore Engineering's design expertise, together with the dedication of all involved, has turned a blueprint into reality.